Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have an exercise. The name of this exercise is Sum and Average of Integers. So write a program to sum a sequence of integers and calculate their average. Assume that the first integer, read with scanf, specifies the number of values to be entered. Your program should read only one value each time scanf is executed. A typical input sequence might be 7 at first, which specifies the number of numbers that is going to be entered: 1, 2, 3, 4, 5, 6, 7, where the 7 indicates that the subsequent 7 values are going to be summed. That's it. Go on and try to solve this problem and come back to this video for the solution. Welcome back, and this is the solution to our problem. First, I have initialized a counter, which this counter is going to be used in this for statement. Secondly, I have used a variable to remember the count of numbers that is going to be entered by the user. So probably the user entered 7 as the first number, and we are going to remember that in this variable using scanf. Now another variable here for the calculating of the sum of all the numbers that is going to be entered by the user. Now we have a for loop. The for loop will start from counter, which is 1, and it will go until this number, count of numbers, which in our case it's 7 numbers. And each time the loop is running, the counter will be added one value at a time. Now we are going to use this variable to store and remember the number that the user is going to enter after 7. And each time the number is entered, we are going to add that number to sum. And this for loop will run for 7 times until all of those 7 numbers are stored in this variable, and all of them are going to be added to the sum. Finally, we are going to calculate the average using this statement, and at the end we are going to print the value of sum and the value of average for all those numbers. Now let's go and run this program. Here, the first number that I'm going to enter is going to specify the subsequent numbers. So maybe I will say 5 numbers. Then I will enter 5 different numbers: 10, 20, 30, 40, and 50. And at the end, you can see that the sum is 150 and the average is 30. That's it for this episode. See you in the coming episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have another exercise for you, converting Celsius to Fahrenheit. So write a program that converts temperatures ranging between 30 Celsius and 50 Celsius to the Fahrenheit scale. The program should print a table displaying temperatures in the two scales side by side. You have the hand, and this is the formula to change Celsius to Fahrenheit. And that's it. Go on and solve this problem and come back to this video for the solution. Hello and welcome back, and this is the solution to the problem that we were discussing about. So here I have declared and initialized an integer value for Celsius. Then I have declared a double value for Fahrenheit, where we will calculate the value of Celsius to Fahrenheit using the formula that we were provided. And in this part we are going to print the header. So let me put a comment, print the header. We will have the distance of one tab between each headers, and then a new line, and then using a for iteration statement we will go from 30 Celsius to 50 Celsius, one step at a time, one counter at a time, and then for each counter we calculate the value of Fahrenheit and we are going to print the value of Celsius and Fahrenheit side by side. And there is one thing that we should do. I think we should remove this part because there is no need for this part, so we can remove it because we are going to calculate the Fahrenheit inside the for loop as well, so there is no need for that. Let's go and execute this program. And as you can see, we got our tables. This is the Celsius table, the equivalent Fahrenheit table in front of it. And that's it for this episode. See you in the coming episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Welcome to this episode, and in this episode we have another exercise calculating the sum of multiples. I want you to write a program to calculate and print the sum of all multiples of 7 from 1 to 100. That's it. This is the exercise for you. Go and solve this problem and come back to this video for the solution. Welcome back, and this is the solution to our problem. First, I have initialized a variable called sum to 0, and we are going to store the sum of all multiples of 7 in this variable. Now I have a for iteration. It will start from 1, it will go until 100, one step at a time, and each time it encounters a multiple of 7, that is the counter divided by 7, and the remainder is equal to 0, that is a multiple of 7. It will print that multiple of 7, and it will also add that multiple of 7 to sum. And finally, at the end of the program, we are going to print the sum. Let's go and execute this problem. Now, as you can see, I have printed each multiple of 7 each time we have encountered to that multiple during executing the program, and that is 7, 14, 21, 28, up until 98, and at the end we have the total sum of all of those numbers. That's it for this episode. See you in the coming episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have an exercise for you, that is the prime numbers. So write a program to calculate and print a list of all prime numbers from 1 to 100. That's it. Go and try to write the solution to this problem and come back to this video if you cannot solve this problem. Hello and welcome back, and this is the solution to the problem that we were talking about. So I want to elaborate the solution a little bit for you. As you can see in here, we have defined a Boolean value, and initially we have assumed that all numbers are actually prime until we prove it that it's not prime. So we have started the count of numbers. We have been told to run from 1 to 100. So initially we do not consider 1 as a prime number, so we start from 2, we will go until 100, and we will increment 1 by 1. Then again we have another for loop, and this for loop, the purpose of this for loop is to prove that if this number is prime or not prime, this number that we have created in this for loop. Now it will create a divisor for each number, and this divisor will start from 2 and it will run until the maximum one value less than the number, and each time the divisor is going to be incremented. So we have a condition in here, and the condition is saying that if this number that we have generated using this for loop is divided by this number, which the divisor that we have created, and the remainder is 0, that means that the number is divisible by this divisor, then this number is actually not prime, and we set this boolean value of is prime to false, and we break the cycle for this for if. And continuing, we will see that is the number still a prime. If that is true, then we are going to print that prime. But if the number was considered as not prime inside this for loop, then this will be false and nothing will happen. And finally, at the end of this for loop, once again we assume that the number is a prime, so that for the next number that is going to be generated, the assumption is going to be correct that it is a prime number until it is proven that it's not. And that's it. We will go and run this program, and as you can see, we have got the prime numbers. 2 is prime, 3, 5, 7, 11 until 97. And that's it for this episode. See you in the coming episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have another exercise that is factorials. The factorial function is used frequently in probability problems. The factorial of a positive integer n, written n factorial and pronounced as n factorial, is equal to the product of the positive integers from 1 through n. So write a program that evaluates the factorials of the integers from 1 to 5. Print the result in a tabular format. What difficulty might prevent you from calculating the factorial of 20? That's it. Go on and solve this problem, and also tell me in the comments section below what difficulty might prevent you from calculating the factorial of 20, or even more, 30, 40. Now go and try to solve this exercise and come back to this video for the solution. Hello and welcome back, and this is the solution to our problem, our factorial problem. I want to elaborate this solution a little bit for you. Initially, I have declared a variable that is going to hold the value of the previous number's factorial, and initially that number is 1. Now you will later see why we have this value. Now I have initialized a for loop. That for loop will start from 1, it will go until 5, and it will increment 1 by 1. Now we want to calculate the factorial. The factorial of a number is the number times the factorial of its previous numbers. For example, the factorial of 5 is equal to 5 times factorial of 4. So basically this is the logic. A factorial of this number is equal to that number times the factorial of its previous number, because this also means that 4 times 3 times 2 times 1, and that's why this logic is correct. And that's what we are trying to do in this program. We are saving this previous number's factorial, and at the end, to find the factorial of the same number, we are going to multiply that number to the factorial of its previous numbers. And at the end, we are going to print the number and also its factorial, And finally, to not lose the value of this factorial of a number, we are going to save that factorial into the previous number's factorial, so that for the next iteration of a for we can use this value. And that's it. This is the logic of the program. Let's go and run it. Now as you can see, I have the factorial of 1 is 1, 2 is 2, 3 is 6, 4 is 24, and 5 is 120. Now if we try to make this number maybe 20, let's go and execute. And now you can see that the number is getting larger very quickly. It's getting a lot larger, and at one point the number overflows. As you can see, the number has overflowed in this point. At factorial of I think 17, it has overflowed. It's beyond the limit of an integer value, and that's why we cannot really calculate the factorial of 20 using an integer value. Maybe we can use long integers, or maybe we can use some other type of data type. That's it for this episode. See you in the coming episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have another exercise for you, triangle printing program. So write a program that prints the following patterns separately, one below the other. Use for loops to generate the patterns. All asterisks should be printed by a single printf statement in the form of this form. And this sentence will cause the asterisks to print side by side. We also have a hint for you. The last two patterns require that each line began with an appropriate number of blanks. So go on and try to solve this problem and come back for the solution on this video. Welcome back, and we have the solution for you in here. First, we are going to talk about the A part of the problem. So for the A part, if you remember, we have 1 asterisk in line 1 and 2 asterisk in line 2 and 3 asterisk in line 3, and that's how it goes. So using this for line, we are going to create lines. So this is for line 1. It will go until 10 lines and 1 line at a time. And what's going to happen inside this for is that we are going to create lines using this puts function. But inside of each line, what's going to happen is that for line 1, for example, we have 1 asterisk, and the number of asterisks is going to continue to the number of lines. So for example, in line 1, there is going to be 1 asterisk printed, and it will continue. Now in line 2, we have the line counter as 2, and then we print 2 asterisks on line 2. And exactly the same way in line 3, we are going to print 3 asterisks using this for loop on line 3, and that's how it goes on. Now let's go and print, for example, for A. As you can see, this is our A and it has printed properly. Now let's go and talk about the B part. So for part B, we assumed that line 1 is line 10. So we started from line 10 and we are going back to line 1. So we start from 10, we are going to line 1, and we are going 1 line at a time, taking a step back. Now for each line, for example, line 1, which is actually in here, it's started as 10. What's going to happen inside this for loop is that many asterisks are going to be printed. So for the first line, which is actually called line 10, 10 asterisks are going to be printed using this for loop. And that's it, as easy as that. Let's go and print it. Now as you can see, this is our first line, but we have assumed that it starts from line 10, and this for loop is going to print that many asterisks on that line. And so that's how this program works. Stay tuned, and I'm going to go on part C and D in a few seconds. Welcome back. Now we want to talk about the C part. In the C part, we also started the line counter from 10, and we are going back to one counter at a time. And now in the line 10, what we are going to do is that we are going to print spaces. The spaces is going to be printed as many as the 10 minus line counter. So the first line counter is 10, 10 minus 10 is going to be 0, so no spaces is going to be printed using this for loop. But instead we are going to have asterisks. And how many asterisks are going to be printed? Since we are on line 10, then 10 asterisks are going to be printed using this for loop. Now if we go to line 9, now it becomes 9, we come to this for loop, this 10 minus 9 becomes 1, then we have one space, and then we have 9 asterisks. And then when it becomes 8, then we have 2 spaces, and then we have 8 asterisks. And that's how it goes on until all of those lines are going to be printed. Now let's talk about the D part of this problem. In the D part, we are going to have 10 lines, obviously. We start from line 10, we are going back to line 1, one step going backward. For line 10, what we are going to do is that we are going to print spaces, but how many spaces? This many spaces, line counter minus 1. So for line 10, we are going to print 9 spaces. And how many asterisks we are going to print for line 10? We are going to print 1 asterisk. 11 minus 10 is 1, so 1 asterisk. Imagine if this becomes 9, then we have 9 minus 1, 8, then we have printed 8 spaces, and then in here it becomes 11 minus 9, it becomes 2, then we print 2 asterisks, and that's how it goes on. The cycle goes on, and that's how we're going to print all those asterisks and lines for part D of our problem. Let's go and run the problem once so that we can see the results. As you can see, this is the C part and this is the D part. Thank you, and I see you in the next episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have another exercise for you. The name of the exercise is Bar Chart Printing Program. So, one interesting application of computers is drawing graphs and bar charts. Write a program that reads 5 numbers, each between 1 and 30. For each number read, your program should print a line containing that number of adjacent asterisks. For example, if your program reads the number 7, it should print 7 asterisks. And that's it. This is the problem. I want you to go and solve this problem on your own and come back to this video for the solution. Welcome back, and this is the solution to the problem that we were discussing about. In here we have 5 variables that are going to store the numbers from the user. Then we have a prompt from the user for the user to enter 5 numbers between 1 and 30. Then we are going to scan those numbers using scanf, and we are going to store them in these numbers in these variables. And finally, using for statements, we are going to print that many asterisks, and there will be a new line between each line of asterisks. And that's it. Let's go and run this program. Let's say 11 10, 15, 22 and 30. Now as you can see, this is the bar chart that we got from these inputs of numbers. And that's it for this episode. See you in the coming episodes. Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have another exercise. The exercise is table of decimal, octal and hexadecimal equivalents. We would like you to write a program that prints a table of the octal and hexadecimal equivalents of the decimal numbers between 1 and 256. If you're not familiar with these number systems, go and read online before you attempt this exercise. And we also have a hint for you that you can display an integer as an octal or hexadecimal value with the conversion specification that are written in here. So go on and try to solve this problem and come back to this video for the solution. Hello and welcome back, and this is the solution to our pi problem. So as you can see, I have defined a double variable called pi, which has an initial value of 4. Now we have a for iteration. It starts with 3. It will go until the value that we have defined, and it will be added by 4 each time. Now pi initially is 4. You know that it's 4. Now 4 minus 4 divided by counter, which is 3, and the type of counter is going to be float, because we do not want it to be an integer, and this part yields an integer. We do not want that. We want it to be float. That's why we have made explicitly the counter as float in this part. Now up until here we have 4 minus 4 over 3. Now in this part we are going to add the value of pi once again to this value, 4 divided to float type of counter plus 2. That would be 4 minus 4 over 3 that we had from previous, plus 4 divided by the counter, which is 3, plus 2 is 5. And that's it. We have got this part until now. Finally, the counter will be added to 4 next time. So next time what we will have is that, let me make these comments so you can see. So for the next time when this counter becomes 4, we have a total of this part already minus the new part in here, which is 4 divided by 3 plus 4 is equal to 7. 4 divided by 7. Now we come to the next line and we already have this part. We will paste it and we want to subtract 4 divided by this part has become 7 plus 2 is 9. 4 over 9. And as you can see, this iteration can go on, and finally we can print the value of 5. Now in here we have done only a few iterations of 4 until 15. Let's go and execute. You can see we have got a value of 3.25, which is still very far away from 3.14. If I try to increase this number and make it probably 150, then we get closer to pi, that is 3.15, which is close to 3.14 for pi. And let's go and even increase this 10 more. Now you will be able to see that we have got the value of pi, but not exactly the value of pi. The more we calculate this equation, the more accurate value of pi we are going to get, 3.142924. And that's it. This is the solution to the problem, and I hope to see you in the coming episodes.